what I did is I told my agent that I wanted to. So right now I'm talking to Claude Code, and we have built agents into a program. So we have a whole program which is flavor.ai, and it is a web, phone, text ordering system, Q&A system that accepts phone calls for restaurants. So when somebody calls the restaurant and they're busy, they can't answer it, Flavor automatically picks up the phone and takes the order. If the customer has questions, then they answer the customer's questions, or they can take the orders or whatever. So now I am working on the prompt itself. So our agent has done really good. We have a full system built out exactly how we want to build it out. We're just going to work on the way that the agent handles the interaction, the voice agent and the web agent. So we have issues like abbreviations, for instance. One of the things that it was doing was that when the agent would take the phone call and you're having a conversation with the agent and they're talking about hamburger sizes, and it was using the menu to abbreviate pound, right? LB. And it was saying ulb, like just ulb, like a third ulb. Well, it's not a third ulb, right? It's a third of a pound. So we go back and we tell our Claude agent, our Claude Code agent, hey, our voice agent is making this mistake. It is taking this abbreviation for pound, LB, and sounding it out like it's the actual word instead of saying pound. So these are things, that was a situation that I went in and I just told my agent to go fix that, and it goes and it fixes that. Now what we're doing here, what you see running in terminal, is we have our agent building prompts. So based off of Karpathy's Autoresearch that he just released a couple weeks ago, which was a recursive AI learning program that he built, which was very simple. It does all these. The AI works in 5-minute increments. 5 minutes, perfect. 5 minutes, boom, 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 and each 5 minutes, each section is scored. And if the next 5-minute score performs worse than the previous 5-minute score, then it's discarded. But if it performs better than the previous 5-minute score, the previous 5-minute score is discarded, and that one is kept as now the new baseline, and a new 5-minute section starts. So you get this recursive training to where it just starts getting incrementally better and better and better and better. And so from that, many people took Karpathy's Autoresearch, which he developed on, I believe he did on NVIDIA H100s, which are very expensive systems, $30,000+. And so you needed one of those to run his Autoresearch. You couldn't do it just on a regular laptop or desktop computer. But people took his Autoresearch project from GitHub, and immediately people went to work and how can we optimize this and how can we make this accessible for regular people with regular laptops? And so somebody, I wish I could give them credit. I need to go back and look, and I'll add it here to the video. But off the top of my head, I don't know. But I saw something on X the other day, and they said, hey, I just published this GitHub repo and I forked, or maybe they didn't fork it, but I think they did fork Karpathy's Autoresearch, and they developed it to work on Apple metal systems, the M chips. So a couple days ago, I took that person's project and took it into my system, my computer, my agent, and all I did is I went to the GitHub where this person had published their new Autoresearch project, and I copied the GitHub link, went and pasted it into my terminal to my Claude Code agent, and I said, hey, can we use this? And it comes back and says, oh my gosh, this is a great project. Yes, we can use it for this, this, and this. And I said, fantastic. And so while the principle is that it's basically just a simple scoring system, this Autoresearch, I am using it for prompting. So we can score our prompts based off of the output. So that's what we're doing here. So let me just go back up and see what they've started working on here. So flavor Autoresearch. The description is to prompt Autoresearch for flavor, voice, and web chat agent prompts. Menu. The input here, we have what burgers do you have? They have it categorized as a menu question. It must mention smash burgers and mushroom Swiss, and must mention pound. So you can see how it's built here, unique. So I've done a few things. Let me go back up to show you. I said I want to work on both the voice and web agents to make sure their prompts are solid. Place in this directory on my system. The persona is the friendly restaurant assistant. The eval categories, menu questions, abbreviation handling, edge cases. Success criteria depends on category. I fired up a local Llama server, integrate with both voice and web agents. So I said that based off of what it had told me. It had asked me these questions when I gave it the Autoresearch prompt, which was a skill that I built into my Claude Code after I had brought that GitHub repo into my system and used it. And I realized, oh my gosh, this is fantastic. So what I told my Claude Code to do was create an Autoresearch skill so we can do this anywhere globally on our system, and any project that we're working on, we can deploy this skill right here, and it's immediately going to go to work and start developing better prompts for us. So this one is specifically working on the menu items and the abbreviations. So we don't want it to say ulb, and we don't want it to say gf if it's GF for gluten-free. We want it to say gluten-free. So what it's going to do is it's going to create all these test scenarios, and it's going to run through all these different tests. And it's literally going to have customer questions asking different questions about the menu. And then the web and voice agents are going to respond to that. And then our agent is going to score their response. And if the response is better than the previous responses that we were getting with the previous prompt, then we're going to modify the prompt to accept the new prompt, which gave us the better score. So it's a roundabout way of saying that if the score's not better, we're discarding it. If the score's better, we're keeping it. And so what it does is it does this over and over and over again until your score gets better, 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 better. And all of a sudden you have a very, very, very high performing prompt that is doing exactly what you want it to. There's going to be very, very, very few scenarios where the edge case falls off. And so we, of course, want to make sure that our prompts are rock solid, because if our prompts aren't rock solid, the natural language that we give the AI agents, then the AI agents are going to hallucinate. They're going to go off the rails a little bit. They might just start, they might do anything. You never really know. So our goal is to put up the guardrails around the AI to make sure that it never falls outside of those bounds. And then also inside of the guardrails, that it's doing everything that it's supposed to do, that it's designed to do. Okay, so it's saying here the scoring highlights: forbidden terms, LB, OZ for ounce, GF, and this is only in voice mode, you see. Instant 0, so they'll score to 0 if that's the case. Filler detection, Great question. Certainly, fabrication, detection, inventing menu items. You see this? So this is amazing. This always just blows my mind every time I see this. We have an AI agent working for us right now, which is Claude Code. I'm using, it says Sonnet 4.6 up here, but I changed it to Opus 4.6. But nonetheless, we have our Claude Code agent working for us. That's this little chat terminal that we're working in. But it realizes as an AI agent, it thinks that it understands that it's an agent, but it also has a side of it that kind of thinks it's a human sometimes too, especially
so you
when
see here,
it gets into
it has started running a new eval for restaurant info
type
cases.
And so
here we go.
Sometimes that works in your favor and sometimes it works against you. But here it's saying our AI agent is implementing a fabrication detection system to prevent against inventing menu items. And so because it knows that AI has the ability and sometimes it hallucinates and will just start doing things and just start saying things confidently. And the person on the other end, the customer calling the restaurant, doesn't know that the mushroom Swiss burger with chili on top is actually a fake made up item. They don't sell those. This restaurant has never sold them. It was the AI just fabricating it. So we use this Autoresearch prompting system to continuously iterate on our prompts and test those prompts to say, is this prompt performing better or worse? And so in this case, if the AI, it's going to test and it's going to push the AI and ask it menu questions specifically. And if those menu questions, if our agent responds with a hallucination of a menu item that does not exist, well, of course, then it's going to score to 0 and then rechange the prompt or change the prompt to tweak it a little bit to try to make it to where the AI does not hallucinate and start creating new menu items. Staff redirect detection for allergen complaint cases. Speed bonus up to 5% for fast responses. To run it, make sure your local or your Llama server is running, which I have it running. Open a new Claude Code session on the project. Use CD Autoresearch. Okay, say read program. Okay, so watch this. So it's wanting me to open a new terminal. So I am going to, give me a second here. New terminal. And screen capture, I think. Turn 2. All right. Window. Okay. So let me pull these side by side over here. And actually, okay, so now in this new terminal that we have open, okay, so it's saying to run it, make sure your Llama server is running, which mine is. And then it's saying open new Claude Code session and go to this directory, which all I have to do is copy and paste, and it will take me to that directory with the Claude Code running. And Actually, before I do that, I am going to escape out of there. And I am just going to go to the directory without starting Claude. Because actually what I want to do is I want to say Claude and then dangerously skip permissions and so let's see, we'll just cd to the directory and then we'll run Claude dangerously skip permissions. Oh, I didn't add the, okay. So now we're where we should be. And so now the agent is saying the set 3 in this process is say, which is saying text to it or send it a message, read program.md and start the loop. So what it did is it went and it created a program.md in our directory in this project, and it gives it the instructions on what to do. And so now this Claude Code session opening up for the very first time is saying, hey, where am I at? What am I doing? It's in this directory that we planted it in. And we're telling it to read that program.md, which has the Autoresearch loop in it. And it's saying, let me get a baseline score and read the eval. Okay. So you see here that it's evaluating it. It's running this Python program and it's going to run an eval right now and just see where it's at. So this eval will be the baseline for our Claude Code or our prompts. So we're going to let this run. And see our first eval. So here I want to show you, this is the Llama server that's running. So this server is the one that's actually doing all the computation. This is the AI agent that is providing, or sorry, this is the AI model that is providing the outputs. And so we are running it. And you see here, it says, talks about the eval time, the tokens that's used, everything. So it's scoring the time, it's scoring the token usage, so it can always optimize for efficiency. We're trying to get less time and fewer tokens with a better quality output. We'll watch these. So here we're going to be able to watch our server run and also watch the output of our Claude Code agent, who is actually the one performing the Autoresearch project. So we have our agent here. You see here, it says the baseline evaluation is running. Let me wait for it to complete. So that's what it did, that evaluation up there. And you see here, it's only saying that it's using 219 tokens. That's because the Llama server is the one doing all the work right now. So our agent here, oh, see something just happened. Creating virtual environment at .venv, running 54 eval cases. So it decided that it's going to use 54. Oh, look at that. We have a baseline score of 0.9327, an accuracy of 0.937, and a pass count of 38 of 54. Main issues, most failures are word count violations, voice response is too long, plus EC16 billing complaint. Uh-oh, do I need to pay my bill? Missing redirect and using a filler. Let me create the result file and start iterating. So here, it did that and it placed these so it can keep count. Now let me try to start the experiment loop. The biggest opportunities are voice response is way too long, needs stronger brevity enforcement. EC16 billing complaint needs redirect to staff and no filler. EC05 triggers fabrication because it mentions pizza even while saying they don't have it. Oh, you see right there, this is what we were talking about. It's fabricating the menu because the caller or the customer on the web, whether it was a phone call or a web chat, mentioned pizza, but the restaurant that we're using, EVthing, shout out to EVthing in Cuero, Texas. I'm using your restaurant information here for menu items and stuff so I can run these tests. And so EVthing apparently does not have, or no, they don't. I don't think they have pizzas. Maybe they do. But anyways, the case at this restaurant is that our eval is set up. You see here that EC05 triggers fabrication. This is what we were talking about because the customer mentioned pizza, but the restaurant doesn't actually serve pizza, but it must have said they had pizza because the customer asked for it. So we need our prompt to be stronger so that the AI agent does not hallucinate and go on with confirming a pizza order when the restaurant does not serve pizza. So in experiment 1, we're enforcing strict word limits and add billing complaint redirect rule. And then this is the code that it's doing that. So you see this is the actual code in our prompt.txt. So this is our file. This is our prompt that is the code that the AI agent is reading through when it's doing all of this stuff, when it's actually live in production and it's taking a real phone call or a real web order. So this one in this case is the voice mode, the rules. So you see here, the red means that it was removed and the green means that it was added in place of. So we're removing this and then we're adding this in place of it. So your responses must be under 25 words for simple questions, and it goes on to tell how to do that. We're removing more and adding more. So this is just iterating on the prompt itself. You see here how at line 52, it basically looks the same for questions outside your knowledge, but notice here, this little part right here is the key point that is changing. Visiting in person or speaking with staff. So our agent, our Claude Code agent, is making these changes in the voice agent's prompt to try to make it have the best output possible, the desired output, what we want, what you would say if you were the person taking the phone call. And so these little changes, just visiting in person, speaking with staff, those changes can change the entire conceptual idea of the conversation, the prompt, the conversation, and what it means, what the actual results that we're trying to get with the customer. And so we're going to go down through here. It's just running all these. Oh, you see here, so it ran it again. And it says huge improvement. We went from a score of 0.9327 to 0.9756. That is a big improvement. The pass count went from 38 to 47. So you see this right here. It's keeping that change. This is the key genius in Karpathy's Autoresearch, which this program is an iteration of that. We are keeping this change based off the sole score. Our score improved. Even if it was just 1/10,000th of a point improvement, we would keep it. But in this case, it is a huge improvement. So we're going from 0.9327 to 0.9756. So it's saying, of course, we're keeping this change. So now the previous change is tossed out the window. The previous prompt is tossed out the window, and we're keeping this prompt, the new prompt, as the baseline. And so it's saying we're going to do experiment 2. Fix remaining failures, add few shot examples. So a few shot is a type of prompt. So you have one shot, few shot, you have all these different types of prompts. And so in this case, it's going to use a few shot for the examples. For the key patterns, allergen query should mention staff. Abbreviations must expand and order confirmations, transfer connect. And so it's going to go on once again. It's not removing things. Notice here, it is only adding things. So it is adding lines 74 through 93 with these new prompts in it. And we look at this. This is amazing. So in each case, and in our first, when we were in the baseline, we were at a 93 or 0.93, whatever it was. And we jumped up to 0.9756. Now look at this. We jumped up from a 0.9756 to 0.9901. That is absolutely amazing. So it shows that right here, that our Autoresearch project that is globally accessible anywhere on our system as a Claude Code skill. All you have to do is run the / command, Autoresearch, and it will scaffold out any project that you have and be able to work on the iteration and the design on a scoring system. So our pass count went from, at first it was 38, then it went to 47. Now we're at 51. And it's saying that abbreviation handling and menu questions are now 100%. Only 3 failures left. So it's committing this. It's going to say in experiment 3, we're going to fix the last 3 failures. Now look at this. So remember it had added all these lines up here, starting with 74. 73 was already present, but in this case, it is removing line 73. It's saying we don't want that one. We're going to replace it with a new line 73 and 74 and 75. Added some few shot examples. And let's see. So now it's running the evaluation. We see it here in our Llama server. Our Llama server is just running. And it's running the eval for experiment 3. And I just love to sit here and watch it work. It is very, very awesome to watch. Because sometimes just, you see this, it's been doing this for the past 16 minutes. It's burned 2,500 tokens doing that, because the beauty of this is I have this local Llama server running. So while I am making external API calls, in this instance running Claude Code, I'm using an Anthropic API key. And when I'm making, when I'm chatting here, when I'm having a conversation back and forth with the agent here, I'm being charged for it because I'm using Anthropic's intelligence through their API keys. So each token costs money. And look at this. Look at this. Perfect score, 1.00. All 54 cases passing. All 284 checks passed. 100% across every category. That is absolutely awesome. It says, let me run it once more to verify this is stable and not a lucky run due to temperature being at 0.7. Okay. And so now that it's saying, hey, we just achieved an absolute perfect score, we are going to not just take that perfect score as being a true result. We're actually going to verify to make sure that it wasn't just an anomaly, that we had a perfect score just slip through the cracks. So it's going to go back through and run a reevaluation of what it did. Likely it will change a few little things to try to get some different types of see if it can get a different result, maybe push the model a little bit to see if our prompts are solid. But I'm going to let it run. It can run all day if it wants to. And then, so with this one right here, it had asked me initially, let me see if I can scroll up. No, it's already passed. But it had asked me, okay, in this project, the flavor.ai project, you have all these different things that we can work on. What do you actually want to work on? And instead of telling the agent to work on all of them, which is a temptation for sure, one thing I've learned that instead of just having them do everything 1 through 6, if this is like a big thing like this, we're going through and we're actually having to do evals on each one of those things. Instead of it going through and trying to do all of them at once, what I'm going to do is I'm going to chunk it, and I'm going to have it do what I'm doing right now is just the menu items and abbreviations. And then after it nails this down, the menu items and abbreviations, after we get those prompts perfect, then I'm going to take another chunk. And this one also handled edge cases, but I'm going to take another chunk of just basic Q&A with like hours, parking lot questions, and things like that will dining, arrangements. Do you have outside seating, no outside seating, things like that, so that our agent is the most capable agent and is fully aware of everything that's going on in the business operations of the restaurant. Not just, hey, we can take your order. It's, hey, we can tell you that that parking is tight after 5 p.m. And you may need to park on the side street, something like that. So these are all things that something like that, an example of a restaurant that has parking, that gets packed after 5 and you need to park on the side street. The cool part about Flavor.ai is that the restaurant owner, the manager, who's ever in charge of the system, they get a nice, simple web dashboard. And in that web dashboard, they can put custom instructions. So if you want your agent to notify the customers that that parking gets tight after 5 and to use the side street, you can put that in as a custom instruction, and your agent will have that in its memory as it converses with every conversation that it has, whether it's on the web or whether it is in a phone call. So the agent is fully capable of running, or at least has the intelligence of what it takes to run the business so it can properly answer customers' questions. So we have some incredibly exciting news. Our tests have completed, and we have a test score of 1.0000 across all runs. That is perfect. So we are going to consider this a finalized run of this prompt. So it's telling us here that the key changes, here it shows us the results from the baseline with the score, a pass count of 38 to 54 with the original prompt, and experiment 1 went from 0.9327 to 0.9756 with 47 passing, and you see the improvements to 0.9901, then 1.0, 1.0. And so key changes that move the needle: explicit word count caps, 25 words simple, 40 words complex, fixed 9 max word failures, few shot examples for voice mode. We added that anti-fabrication rule, don't repeat the food name they asked about, prevented the false positives. Complaint reservation redirects, price formatting, 2.00, not 2 to match exact trait checks. Interesting that you see how it's making sure that it can properly digest the input to give the right output. The prompt is now stable at perfect score across 3 consecutive runs, despite a temperature of 0.7, meaning that is the flexibility that it gives in the AI. The higher the temperature, the more confined it is. The lower the temperature, the more that it can experiment with the prompt. Okay, so we're saying we have a perfect score. 1.0 across all 3 of our areas that we ran it here. Yeah, or across all runs. So now we're going to work on a Q&A prompt to make sure that our Q&As are proper, make sure our parking lot rules are set properly as far as in the prompting, And so let's do that now. Let's say, okay, great. Now let's work on other areas other prompt areas to improve, like basic Q and A, including questions about hours, dining, room arrangements, inside, outside, dining, parking lots, street parking, etc. Busy hours, etc. So let's see what it says here. So now I want it to continue our auto research project, and it's saying, let me check what restaurant info we have available and what's already covered in the eval set. And it's going to start working away.